All right, ladies and gentlemen, welcome back to another one of Miss Lynch's delicious math videos. Today we're going to talk about simplifying imaginary roots. So let's talk about what a square root is. So the square root of 25 is 5. Why is that? Well, that's because 5 times 5 gives you 25. So the square root of 25 is 5. What's the square root of 81? Well, that's 9 times 9, so the square root of 81 is 9, right? Because 9 times itself gives you 81. The square root of 81 is 9. Following this logic, what is the square root of negative 1? Well, to get negative 1, I can multiply negative 1 times 1. Oh dear. The only way to get negative 1 is to multiply negative 1 times 1. These two numbers are not the same. So how can I take the square root of a number that I can't even get this number by multiplying two of the same numbers? Well, us math people have come up with a solution for this. We call it I. The square root of negative 1 is I, or imaginary. The imaginary number. Now, I is absolutely great because you can do all kinds of things with I. For instance, you can take I to the power of 2. I to the power of 2 is the same thing as I times I, which could also be said to be the square root of negative 1 times the square root of negative 1, which is negative 1. How interesting. An imaginary number can turn into a real number simply by squaring it. What is I to the power of 3? Well, that is simply I times I times I, or the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, that's the same thing as negative 1 times the square root of negative 1, or negative I. What is I to the 4? Well, that's I times I times I times I, which is the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, these two, if I multiply the square root of negative 1 times the square root of negative 1, I get negative 1. And if I multiply these two, square root of negative 1 times square root of negative 1, I also get negative 1. So negative 1 times negative 1 is 1. Isn't I a really cool number? Now let's see how this works when we're trying to simplify roots. So what we're going to do is simplify each of these roots. Example 1. Let's say we're given the square root of negative 4. Now, we know the square root of 4, but are there two numbers that are exactly the same that when you multiply them you'll get negative 4? No. But you can get negative 4 by multiplying the square root of 4 times the square root of negative 1. All right, well, the square root of 4 is 2. The square root of negative 1 is I. So the square root of negative 4 is 2I. Let's do negative square root of negative 36. Okay, let's break that down. Now the negative is still on the outside. That's the same thing as the negative square root of 36 times the square root of negative 1. Well, the square root of 36 is 6, so that's negative 6 times I. Let's do another one. Let's do the square root of negative 96. Now, 96 is not a perfect square, but I can break it down into a perfect square. So let's say that would actually be the square root of 16 times the square root of 6 times the square root of negative 1, because 16 times 6 times negative 1 is negative 96. So that's 4 times the square root of 6, that's square root, times I. Ta-da! And here's one more for you to try. Try to simplify the square root of negative 200. On your mark, get set, go. All right, so let's see what you got. So that's the same thing as the square root of 100 times the square root of 2 times the square root of negative 1. So that's 10 square root 2I. There we are. Now, you will have to rationalize your denominator, so let's talk about that really quickly. Rationalize the denominator. When you rationalize the denominator, basically what you're doing is you're keeping all of the radicals or all of the square roots out of the denominator. You're turning the denominator into a rational number. Okay? So, for example, and you did this a lot in geometry. So, for example, we have 3 over the square root of 2. Well, what I would do with that, I'd take 3 over the square root of 2. Now, I want to get this square root out of the denominator without actually changing the value of my fraction. So I'm going to multiply this guy by 1, because multiplying by 1 does not change the value. But I'm going to write that number 1 very strategically. I'm going to write the number 1 as the square root of 2 over the square root of 2. Now that is going to be great, because now in the numerator I have 3 times the square root of 2, and in the denominator I have 2. The square root of 2 times square root of 2 is 2. Now I don't have a radical in the denominator. Let's see, what if I have 4 over the square root of 6? If you remember, press pause and try this one yourself. I want to take 4 over the square root of 6, and I want to multiply that by the number 1 written very strategically. I want to write the number 1 as the square root of 6 over the square root of 6. Now that's great, because that leaves me with 4 times the square root of 6 over 6. But I'm not finished there. I need to simplify. 4 over 6 simplifies by 2. So I end up with 2 square root of 6 over 3, because 4 over 6 is 2/3. Let's see. What if I have an I? So let's say I have 5 over 3I. Now remember, I is, we talked about this earlier, I is the square root of negative 1. So since I is a square root, he cannot stay in the denominator. So I'm going to do the same thing I did before. I'm going to take my fraction, I'm going to multiply by 1. This time I'm going to write the number 1 as I over I. So in the numerator now I have 5I over 3I squared. But I squared is negative 1. So that's the same thing as 5I over 3 times negative 1. Totally out of space, which is the same thing as 5I over 3. And now my fraction is negative. That's how you do it.